Welcome to On Chemistry. This is Organic Chemistry series. We are seeing the concepts. In this video, we will see IUPAC nomenclature, particularly for bicyclo compounds, the compounds with bridge, the compounds with heteroatom, and compounds with beautiful, attractive structures. Let us define what is bicyclo compounds. Normally, three types of compounds known. They are like multi-fused rings. The spiro is very common, two rings connected through single carbon. But our interest is bicyclo, that is fused system, meaning two rings connected through two carbons, and bicyclic compound, which is the bridge established through the carbons. The same two carbon, but it is established through bridge. Mostly it's a bicyclic. Fused carbon is bicyclic, but one bridge is option. Let us see some interesting fact. Most of the time the compounds are represented in the paper, but it often misleading because you can write 2D in a beautiful way, but in reality it is in the bridge. If you look at the first compound, the bridge is there, but if you draw it with simple 2D structure, it will be attractive. But I would suggest you draw proper 3D structure for easy understanding as well as IUPAC nomenclature. Let us see how you name it by the IUPAC nomenclature. First you should count total carbon atoms, then you find the bridge and you have to count how many different bridged carbons are there. You can call it as XYZ. Then we write the name as bicyclo XYZ. The XYZ should be on descending order. Then the very important fact here is high carbon ring has high priority. Even the smaller ring has functional groups. Here I given the simple compound. You have to find the bridged carbon. Then if you look at it, it has two carbon which is green and one carbon which is pink and three carbons which is blue color. So three different set of carbons connected through the two carbons. So the name contains bicyclo 3,2,1 octane. We will learn by the example. The octane name comes from the fact that total number of carbon atoms, 8 mean octane. The other rules of IUPAC is common, so you apply the same, but you should careful with the priority of the rings. We will learn the nomenclature by the example. Here if you look at the first example, it is very simple one. If you look at it, it has three different bridged carbons. One side 2, another side 2, another side 1. So if you write it, it should be a heptane because it has 7 carbon atoms. 2,2,1 carbon architecture. So if you write in the descending order 2,2,1, so name will be bicyclo 2,2,1 heptane. Heptane stands for 7 carbon atom, 2 for 2 carbon ring, another 2 for another ring, 1 for individual bridge. So 2,2,1 heptane. Let us look at the second example. It is the interesting one with borane, the heteroatom in the structure. The very critical fact here is we should count borane as the carbon. If you look at it, it has 8 carbon and 1 boron, totally 9, so it's nonane. You start the numbering. As we seen already, highest bridge has highest numbering. So if you look at it, it has boron at the 9th position, the least position. Then if you count all the side carbon mean, one side it is 3, another side 3, borane side 1. Borane also should be counted as carbon. So if you look at the name, the normal name will be bicyclo, 3 carbon one side, 3 carbon another side, 1 carbon as the boron. So bicyclo nonane, but you should specify the boron. Boron in the 9th position. So 9 bora bicyclo 3,3,1 nonane. Then the example 3. Here you have bridged carbon with the substitution of bromine. It's an important one because bromine in the lower carbon cycle. First let us look at the carbon. Totally 7 carbons are there. It's heptane. And numbering you start from big ring to small ring. Big ring will be 3 carbon ring. So number will be starts there to 5. Then bromine at the 6th position. But don't confuse with the normal nomenclature. Even though bromine is the functional group, the ring has highest priority. So bromine in the sixth position. If you look at the name, 3 carbon one side, 2 carbon another side, one is the single carbon system. Here bromine at the second ring carbon. So the name will be bromine at sixth position. So 6 bromo bicyclo 321, totally 8 carbon 8 octane. The name should not be confused like 2 bromo bicyclooctane, even it has bromine in it. If you count the total carbon atom, the carbon atoms will be 8, so the parent will be octane. Then the example 4, here it's a simple butterfly kind of compound. The bridged carbon is not there. Here it is 2 cycles through fused carbon. So the parent carbon will be 4 carbon atoms. It is 4, so butane. Then if you look at the bridge, one bridge is absent, so it's 0. Both sides is 1 carbon. So the name will be 110. Third bridge is not there, so that's why we mention it as 0. So if you look at the name, the parent will be on butane, bicyclo structure, but one bridge is not there, mean bicyclo 110 butane. Then let us look at the example 5. It's a Decalin system. It can be simple Decalin or chair form of Decalin, doesn't matter. We have nomenclature here. Here 2 carbon fused 6 member ring, but 2 carbon on middle. So if you look at the parent, totally 10 carbon, so it's a decane. Then if you look at the both side carbons, 4 and 4, third bridge is option, so it's 0. So 440. You have 10 carbon atom with 440. So the name will be bicyclo 440 decane. So fused carbon system name is easy because one bridge is not there. So naming will be easy. Then the example 6, the attractive compound. If you look at it, cyclohexane with middle 2 carbon atom, it can be written many ways. Here I given few ways. But if you redraw properly, it's a simple bridged 2 carbon system. If you look at the parent, totally 8 carbon atoms, it is octane. Then no substitution. So if you look at it, 2 carbon on all the sides, so 2, 2, 2. So parent is 8 mean octane, bridges are 2, 2 mean. The system is bicyclo 222 octane. Then the example 7, cyclohexane with bridged carbon atom. If you redraw properly for our understanding, it's a 1 carbon more bicyclic system. If you look at the total carbon atom, it is 7 carbon atom, so it's a heptane system. And the numbering, if you look at it, 3 carbon on one side, 1 carbon on the another side. So it's a 3-1-1 system. So the naming will be bicyclo 3-1-1-1 heptane. Then the next example, it's a bridged system with complicated substitution. If you draw the numbering and total carbon atom, it is 10. Don't count the side chain, only count the atoms in the bridge as well as cycle. Here if you look at it, we don't count methyl and ethyl. So total carbon will be 10, not 13. Then we look at the position. The numbering should start from higher the ring. So higher ring start means both side equal, but one side it has substitution. So 1 and second will be unsubstituted methyl group, then 3, 4, then the next ring will be 6, 7, 8. Bridge comes least even with ethyl, so 9, 10. So the parent will be 10, it is decane. If you look at the bridge, it has 3, 3, 2 system, 3, 3 carbons on side and 2 on the bridge, and methyl and ethyl is there. Ethyl is 10th position, methyl in 2nd position. So the name will be 10 ethyl 2 methyl bicyclo 332 decane. Then the example 9, simple one, fused system. If you look at it, it has 6 carbon atom, 2 carbon atoms connected through middle bridged carbon atom. Here third bridge is option. Here the parent carbon is 6, so it is hexane. If you count the bridge 2, 2, because either side same number of atoms 2, 2. No bridge is there at that position, so it is 0. So 220. So the naming will be bicyclo 220 hexane. Then the example 10. Here you have pentane with one bridged carbon. If you look at it, if you redraw nicely, you have proper 3D structure, bicyclic compound. The parent will be 6 carbon system, so it is hexane. Then if you look at the numbering on both sides, it has 2 1 1 carbon architecture. If you draw descending order 2 1 1 1, so the naming will be bicyclo, 6 carbon atom, 2 1 1 on side means bicyclo 2 1 1 1 hexane. Then the example 11, fused system with alkene and methyl group. Here total carbon atom you should count. You should not count the methyl groups because you should count the carbon only on the ring. Methyl is away. So totally 10 carbon atoms. It is decane. Then through the bridged carbon, 4 on the other side, and third is option mean 0. Then you have alkene in the system. Alkene in the third position. 3 and 4 will be the methyl groups. You should specify methyl. So 3,4 dimethyl bicyclo 4,4,0 take 3 in. Normal nomenclature will apply. Alkene get priority. Mostly it will come on suffix. So dec 3 in will be the proper nomenclature. So whenever alkene comes, should properly mention as the suffix. Then the example 12. You have bicyclic system with 2 alkene and 2 methyl groups. If you look at it, the system has 7 carbon, so it's a heptane parent. And at the bridged carbon, 2 carbons on either side with 1. So naming is 2 2 1, and you have 2 alkenes are there. The alkene with substitution has higher priority than alkene without substitution. So the 2 methyl and 3 methyl gets higher priority. So the naming starts with 2,3 dimethyl, and you have 2 alkanes, so it's a diene. So the naming will be 2,3 dimethyl bicyclo 2,2,1 hepta 2,5 diene. Then the example 13. The problem given in the plain side. If you redraw nicely, you have alkene and 3 side and 1 side bridge. Where the numbering will start mean numbering start from higher the ring. So 3 carbon ring get higher priority even though without functional group alkene. So the numbering starts there, then comes to the alkene part, finally comes to bridge. So if you look at the numbering, the parent gets 8 carbon without side methyl group. So it's a octane system. Then if you look at the bridged carbons, 3 2 1 on the side, 3 carbon in the big bridge and 1 in alkene, 1 in ethyl group. So name will be on 8th position ethyl group and 1 2 position dimethyl group and 6th position alkene. Alkene is the parent, will come as the suffix. So the name will be 8 ethyl 1 2 dimethyl bicyclo 3 2 1 oct 6-ene. So the ring priority and the numbering, you should be very careful. Next we see the example 14. Here you have bridged carbon with many carbon atoms. So if you look at the total carbon atoms, it is 12. You have to count the bridge and all cycles. So 12 means decane. Then you have to number them in the descending way. If you look at it, 6 carbon on one side, 2 carbon on another side. So parent is decane. So the name will be bicyclo 6,2,2 decane. Then the example 15. You have cyclohexane fused with cyclopropane with alcohol and chloride, 2 functional groups. Here if you look at it, the numbering start from big to small. So 6 member gets high priority, then comes 1. Third bridge is absent, so it is 0. So total carbon atom, the parent, you should count it as 7. So 7, and how many after the bridge means 4 on one side, 1 on another side, third is not there, 0. The real problem comes on numbering. Big ring gets high priority, so the numbering start from there, then go to OH, so it's 2 OH, end up with 7, which is chloride there, so 7 chloride. So if you name it, it will be 7 chloro bicyclo 4,1,0 heptane 2-ol, because alcohol comes as suffix, so it's a heptane 2-ol. The important fact you should know here is The ring gets priority, not the functional groups. Then the example 16. Here you have fused system. If you look at it, it has alkene and cyanide as the functional group. If you want to name it, you start from the higher ring to smaller ring. But at first, you should count total carbon atoms. Total carbon atoms are 8 and the numbering start from big ring. So if you look at it, 3 will come for cyanide, 6 will come for alkene, and you have bicyclo system with 3 carbon on one side, 2 carbon on another side, and 1 carbon on the bridge. So 3 to 1 system. Here obviously big rings get priority. So the name will be bicyclo 3 to 1 oct 6 ene 3 carbonitrile. Then the very interesting compound, heterocyclic compound with 2 bridged carbon and nitrogen. Here nitrogen, you should know the fact that you should count nitrogen as the carbon. So the parent will be 6 carbon and 2 nitrogen mean 8. 8 comes mean octane. Here you should specify nitrogen. So azo will come and you have 2 nitrogen. So diazo. If you look at the ring numbers, all side it has 222, so the name will be 222 alkane. So the parent will be octane with azo position, so the name will be diazo bicyclo 222 octane. Then the example 18, you have butterfly kind of structure. If you number it, you have 5 carbon system, it is pentane, so the parent is pentane. Bridged carbon all are equal 111 size, so the naming will be bicyclo 111 pentane. So always you should count parent as well as count the bridges here. Here you have bridged compound with either side 3 carbon atom. If you count total carbon atom, you have 9. So it's a non-end system. And if you look at the numbering, 3 carbon on one side, 3 carbon on another side, 1 on the bridge. So if you arrange descending order 3, 3, 1, parent will be non-end. So the name will be bicyclo 331 non-end. Then the example 20, camber kind of architecture. Here you have bridge with 2-methyl and side methyl. If you redraw properly for our naming, you have 3 carbon on one side, 1 on another side. Here big rings get higher priority. So first let us look at the total carbon atoms. It has 7 carbon atoms. You should not count methyl here. So heptane system. The numbering will be 311. 3 gets high numbering and 2 rings have same number of carbon atom but one with substitution has higher priority. So methyl group gets 6 and another 1 carbon system gets 7. So it has 3 methyl which is on 2 position and 6 position. So the name will be 2,6,6 trimethyl bicyclo 3111 heptane. Then the last example, you have bicyclic system with ketone and methyl group. If you look at the numbering, parent carbon has 7, so it will be a heptane system. It has one functional group carbonyl. So the numbering if you start from functional group side because it has similar carbon architecture. So 2 gets ketone and methyl gets 7th position. So you have 3 methyl which is 177 and 2 ketone position. If you have same number, more substitute will get high priority. So the naming will be 177 trimethyl bicyclo 221 hep21. See the fact you should learn here is if you have similar carbon architecture, then you go for normal IUPAC rule, which is functional group gets high priority. That's all from this video. Thanks for watching. If you have any suggestion or feedback, comment below.